some things that we need to be aware of. So right here I have an example of a structure named customer, and the customer I'd like to use as a base class, because for example I can have also structure company or organization which derives publicly from customer, and it means that my company will inherit both the phone and the address, and will have both of these data attributes. And we can add here some new attributes, like for instance the name of the company. So I just can use a string for company name. Okay, so company will have a name, and also maybe another registration number. Okay, some sort of registration number. Okay, so we have this. And then I also would like to have another type of customer in my system, which is a person, right? So individual customer, not a company. And in this case, I could have, I can add specifically first name, right? So I can say first name and then last name. So these are my classes, and so they look a little different, but this is the hierarchy that I have. Both person and company derive from customer. So we have one base class and two derived classes in this situation. So potentially I can define a function named operator equals, which is the assignment operator. So so just to show you, before I even add this, if I create a customer, which is a base class, right? Customer, right? Customer. And then I create another customer, the second customer, like this. And I can even initialize them because they are structures. So the phone number will be 123456789, something like this, and the address will be 123 Main Street. Okay, so this will be populated, and the second customer I also would like to provide with some values. So this will be 456 Pleasant Street. Okay, and the number, for the sake of the difference, we'll just use something like 111-222-3344. Okay, so just to make them look different, I can then say customer 2 equals customer, and what this will do, this will simply assign these values to the data attributes of the customer. Basically, the assignment operator is automatically generated for data structures and the classes that we design. So creation of an operator is automatic. But if you don't like or if you need something special to do during the assignment, this is where I would like to add an operator equals. So this operator equals will be a function which will take as a parameter customer constant reference to another customer. So this will be another customer, and it will return back reference to customer. So a standard way of defining such function would be, I'll just write it in line like this, is to say if this object address is the same as the address of another object, we need to return dereference this, meaning that we're all done. This is self-assignment. If just it happens to be that because when we say this customer2 equals customer, okay, this in this very attempt to use this operator, customer2 is this, and customer is another. Okay, so this is another object, customer, and this is the address of the customer2 for which this assignment operator was invoked. Okay, so this is basically the left-hand side of the assignment, and this is the right-hand side of the assignment. And so if this looks like this, so the address of the customer is the same as the address of the customer on the other side of the assignment, then we don't want to do anything, so we say skip. Okay. All right, so then I'll just do, it's just kind of silly to do this, but because I really don't have a good idea why would I override this operator, why would I make it custom version of it, but just for the sake of demonstration, I'll just say that we just simply assign these values, okay, like this. And so same thing with the address, right? So address equals another address. So this way, all we do is just simply, and this is exactly the code that's automatically generated for us. So you don't have to write this function, but I do this for the sake of demonstration. And let's, at least something that we can observe in debugging is that we can say standard output and display which function is running, right? So every time function is invoked, it's underscore underscore function uppercase and underscore underscore, and we'll display new line. So this is just to indicate that this operator was invoked by the compiler. Okay, and then we do our assignment. So this is fine, so let's run this. I'll press Control Build first, and then Control F. It just gives me a warning here, and the warning says not all control paths return a value. That's correct. So I need to say return dereference this. It's the standard way of returning from the assignment operator. Just provide the instance of our object. We have an address of it, we dereference this address, so it becomes the actual object, which is good to initialize a reference to the customer that we need to return from our assignment operator. And this is done for this like this. It's a requirement for the assignment operator, because if you want to say customer, if we had customer 3 equals customer 2, then this kind of reference returned from every operator will allow compiler to make a code which will do assignment this way, then this way, and we can chain it more like this, you know, for more. So this assignment statement can just go more and more and more and more and more things being assigned. So this is the reason why we need to return a reference to this object that's being assigned. Okay, so I'll just continue with the simple example. And so let's first run this, like we said, run this. And you can see that the result of this assignment is that we print the name of the function right here, underscore underscore function, and this is what it is. Okay, so it uses this, it has the string of characters that identifies this function operator. Of course, it's an assignment operator overloaded inside customer structure, and it's all very predictable. Okay, so then let's construct a company.